Hello, Yuri. Can you hear us?
Yes, yes,
Yes.
I can hear you.
Okay, you can share your webcam.
Okay.
Okay.
All right.
Okay,
Hey,
and Adam is here as well. Okay. All right,
hello.
Adam. I think Jaideep is here as well, so Jaideep can also share. So we can get started.
Are the students here?
Yes, I see around 20 of them.
Okay.
Yes. So hello everyone, and welcome to first ACAD's lecture on Introduction to Data Science. And we are happy that we have some of our instructors and faculty members like Professor Neil Snygert, who's one of the co-founders, and Jaideep Vaidya, Yuri is also there. They have joined us for this session. My name is Manish Singh, and I am a quantitative trader at a hedge fund where I use a statistical model for trading global financial markets. So I use data science on a daily basis, and that's my job. There is a lot of confusion these days related to data science. It has become a buzzword. So everyone without even knowing what a standard deviation is trying to learn machine learning, which is a big problem, and it doesn't take you anywhere. And the purpose of ACADS is to give you right foundation and bring in top quality courses, which is at par with the best being taught at the top US universities, and make it affordable to a lot more people so that people have accessibility to these kind of subjects and get understanding of what a data science is. I would also at ACADS, our philosophy is that it's not that we will be teaching you, we will be providing you with all the resources and support so that you can learn. But ultimately, you have to work on the subject. You have to do the assignments, you have to work during a TA sessions, you have to ask questions, and you have to participate in discussions, and that's the only way you can learn. There's no cost of asking questions, but there is a cost of not asking questions. So the not asking questions can cost you later. So feel free to ask questions during TA sessions. Uh, I'll pass on I'll ask Professor Neil Snygert to say a few words. Professor Neil Snygert has been a professor of mathematics at U Chicago since 1982. He holds PhD in mathematics from MIT. He started teaching quantitative finance and data science when very few people heard about it. He was the founding director of a financial mathematics program at University of Chicago in 1996, and he ran that program for a very long time. In addition to that, he also taught at Princeton University in the past, and he's a very well recognized scientist in the area of quantitative finance. So I'll ask Professor Neil Snygert to say a few words on this data science.
All right. Thank you, Manish. Yeah, I'd also like to welcome you all to this course. The way we have chosen to build up courses on data science is that we're gonna build up the foundations first, because that's what we think is really important. It's very easy to take some model and just feed some data into it without understanding what's going on. But that's not the approach we're taking. So we really feel that it's important to learn the basics, statistics, probability theory, programming. The courses that we're teaching here at ACADS is pretty much similar to courses that would be taught in the financial mathematics program at the University of Chicago. And Adam, who's going to be the instructor for this course, he and I have known each other for more years than I
Too long to admit.
remember. A long time. And we have also worked together at the financial math program and are still doing that. So Adam is also, he has a PhD from the University of Chicago, so he's a very competent man. And some of you may have taken the Python course, and some of you may not have taken it, but What Adam is going to be doing is to use R, and we think that to be a real competent data scientist, it's necessary that you know both R and Python. So R is the language of choice for Adam here. Later on, I'll be teaching a course on probability theory for machine learning, and I'll be using Python. But as I said, it's important that one master both of these languages. Both of them are heavily used in the industry. And the industry is not just finance, but it's everywhere. So data analysis and data science is everywhere. So the possibility for advancing in the industry, any industry, are fantastic. There's a huge demand for people who understand data science. So by coming to this program, I think you made the right choice, and we really look forward to teaching you and hearing your questions and help you get ahead in your careers. So thank you.
Thank you, Professor Nygaard. I will ask Professor Jaideep Vaidya to say a few words. Professor Jaideep Vaidya is a professor in the Department of Computer Information Systems at Rutgers University since 2004. At a very early age, he has become a full professor. He has over 140 research papers in the area of data mining, data management, data security. Also, he has published books, which is available on Amazon. I'm not asking to buy it, but probably you may want to buy that book. Those very good books. Also, Professor Jaideep Vaidya has been very much involved in the data security community, and he is a vice chair of SIM activity group in the area of data mining and analytics. And Professor Jaideep Vaidya holds a PhD in computer science from Purdue University. So I'll ask Professor Jaideep Vaidya to say a few words.
Thank you, Manish, for that kind introduction. I would like to echo Neil's words and Manish's as well in welcoming everyone to this course. Data science is indeed the key. You've heard all around that we have data. That's true. The statistics about how much data are themselves staggering in effect. But there's a lot of value in the data. But beyond going into that, I really want to actually commend the dedication, I think, of all of the students who, instead of watching the IPL final, are here. So for those of you who are not aware, which is probably the rest of our instructors, the IPL is a big cricket tournament played in India. It's a huge deal. But what is interesting is that actually uses a lot of data analytics as well. So even though you're missing the final today, think that you may be impacting something of that scope or caliber. Because if you're thinking about auctions in the IPL, if you're thinking, as a matter of fact, there is a lot of research in basically using data mining, data science, data analytics in the world of sports. It's been very popular here in the US, where for ages, you've had baseball statistics, you've had basketball, where you've been trying to use data science techniques to improve the quality of play, and that's happening in cricket, for example, as well. Okay, so in effect, I must say, buzzwords come and go. Data science has been around, since the dawn of statistics, right? So it's been there for centuries in effect. But data is only going to increase. So I think learning how to model it, learning how to analyze it, or to realize the value of it is something that is going to stand you in good stead. It's very important that you get the basic skills from this, because that's something that's just going to grow. It may be a different word that may be used, but these basic skills are going to be useful for you essentially for the rest of your life. So I really welcome you to this course.
Thanks, Jaideep. We'll ask Dr. Yuri Balasanovs to say a few words. Hey, Yuri, we cannot see your, I think your webcam is not started, but it's okay.
It's not? Okay, I will. It says people can see you, but let me try.
Only if you are a logo for UCAM 5. And
I have a logo, yeah.
You weren't.
Yeah, I see the logo, but
It's
I'll
okay.
figure out later how to
Yeah.
start my webcam. Hello everybody. My name is Yuri Balasanov, and I'm happy to be part of the team with the CADS. I got my degrees, including PhD, from Moscow State University, and I studied probability theory and data analysis so many years ago. Like Niels, I will not admit the number. And I've been teaching this subject for all my life, and I've also been doing real analysis of data. There is some noise here. I'm the only one who hears it.
Yeah.
I've been involved in data analysis for a very long time, and what I can tell you is that what I have learned as a student in this subject would have been completely irrelevant now if I didn't go with the flow and I didn't learn constantly and add additional skills to skills that I've learned long ago. This is it my noise or somebody else's?
We
I'm
hear
not
a bit.
hearing.
I hear a lot of noise. I'm sorry. Okay. So what really has changed since then is not the size of data, but the way we ask questions and the questions themselves. And that requires a new approach, new way of thinking. And I'm very happy that with this organization, with the CADS, we have a chance to give a real knowledge about this subject, because this is very important now, not just to know traditional approaches, but learn on practice and with new programming languages, new theory and the old theory, and how all of this comes together in real analysis. That's what I wanted to say as my first message. Thank you.
Okay, thanks a lot, Yuri. So I will pass over to now Adam and Stephen, who will be running this course. So Adam, to you.
Maybe Stephen should go first, because after my introduction, I'll just segue directly into the lecture for today.
Okay.
Sure. So I'll be the TA for the course. Doing my PhD right now in applied mathematics. I've been doing data science for a while now. I'm also working at a hedge fund in Toronto where I'm applying data science to the financial world. Data science is one of those things that's really fun to do, or at least in my opinion, because it can be applied in so many different ways and so many different applications. It's not just the financial world, it's the medical world, it's the sports world, it's everywhere. So as you start learning it, you can kind of take your own direction with whatever you're interested in. I do a lot of natural language processing as one of my main topics, which that on its own is a lot of fun. I don't know if we'll get into natural language processing here, but nevertheless, just the whole learning process is a lot of fun for data science. So I'll basically be here for the course to support you and answer any questions you have. We'll be running weekly tutorial sessions. I'll schedule those probably later today to determine what works best for everyone.
Okay. Okay, I'm Adam Janensky. A little bit about my background. As Neil said, I have a PhD from the University of Chicago. I'm not afraid to admit when I got it, because I received my PhD in 2008, not so long ago. But that's a bit of a cheat, because I was a graduate student at a time way before then, and I won't mention that date. And in 1982, I went to New York for the year with my thesis advisor. I guess you kind of know the date now. And during that year, I became very involved in trading. And so after 1982, I quit being a professional graduate student to become a professional trader. And I spent most of my adult life as a trader. I was a trader on the floor of the New York Stock Exchange, NICE, New York Futures Exchange, the COMEX, and most of my life at the Chicago Mercantile Exchange. And so for 25 years as a option trader, I got to get a very extended and granular look at statistics and realize how important it is for doing finance and many other things. In 2008, as I said, I did go back and I wrote up my thesis and got my degree, and I became involved in more abstract things. I became a quantitative analysis for WH trading, which is a time in which I really started getting my computer skills and really understanding how data science works. And I just realized that, well, I was like finance, I just found data science in general.
Okay, all our class চলছে ও যদি চুপচাপ করতে
Somebody
পারে
has
তাহলে
their to mute their microphone.
Adam, I think only you can, sorry, Adam, only you, I'm making a presenter so you can have everyone on mute and you can have your microphone on. Sorry.
Show my screen. I'm going to show my screen.
Yes.
All right. So after 2008, I became much more involved in the data science, and I came to realize that this was what interested me. I currently work as a consultant, and I consult in data science, predictive analytics. I think Vadia was saying that buzzwords come and go, and so I'll just say, pick your favorite one. That's what I do, and I've just come to really appreciate, as with Steve, how enjoyable it is to do this kind of thing and how interesting it is. I just want to echo what Niels and Yuri said, that it's important to stay current but also have a good foundation. And the purpose of this course will be to teach you R, which is an important computer programming language, by doing. And the doing will be to teach you some statistics, which I think is fundamental to understanding what's going on. You can teach anybody the current state of the art of what's models and which buttons to push. But the bottom line is, with modern artificial intelligence, another great buzzword, those skills are going to go away because in 2 years they're going to have machines that'll push buttons quicker and more appropriately than you. So the only way to really be involved in this is to understand what you're doing. And so that's the purpose of the class. Yeah, and so as to the actual lectures, videos will be created. And in addition, there is, well, it's an HTML document that shows up looking like a PowerPoint. These will both be available on the ACADS, via ACADS after the talk, as soon as, well, reasonably soon after the talk. So let's get started. Okay, I'm going to briefly go to my R screen to make sure I have the latest version. Okay, so this is an introduction to R and R Studio. This is lecture 0. This is not one of the official 10 lectures. I just wanted to have a brief lecture to, in case people are not so familiar with R and R Studio, to get a little bit used to it, see it in action so they'll feel more comfortable using it, because we are going to use R and R Studio integrally with learning statistics. It's a significant portion of what we're going to do is to do the R. I mean, it's pointless to just learn R commands and not understand what they mean, but if you don't know how to implement an R, it's a waste. There's a statistician named Brad Efron, who's a very well-known and deservedly well-known statistician, who in the 1970s wrote a paper on a new technique he had invented called bootstrapping. And what he said at the time was, prior to the 1970s, with the advent of really powerful computers, techniques like bootstrapping were useless to think about inventing because no one could implement them. They just were too computationally intensive. So you can imagine, here we are 40 years later, and computers, according to Moore's law, some huge number of magnitudes more powerful. How important it is to understand how to implement your techniques in computers, because the techniques that are discussed frequently only make sense if you have computers. So R is a programming language. I feel very strongly it's here to stay, and the reason why is R was invented essentially to do computations. I mean, there was actually another language called S, and R was a freeware version of it, and R has absolutely dominated, much like Linux and Unix. And in the world of statistics, essentially there isn't a single thing you can do that doesn't have an R package associated to it. RStudio is an IDE, an interface for using R. That's very nice, very convenient. This link here, which is not a link on your screen, is a link to an IDE cheat sheet. Actually, but that's the wrong one. Sorry. That looks like this. And if you're not familiar with R and RStudio, this is a very nice thing to have. Okay. Here we are. So RStudio is an IDE, and it's very useful. If anyone finds this font too small, please let me know. I enlarged the font, so hopefully it's large enough you can see what I'm doing. So this lower left screen is the console. It's labeled as such. The console is where you could actually type in commands. It's going to say false, or you could say, I don't know, let me...
Hey, sorry, Adam,
yeah?
sorry to interrupt. While Niels, Jaideep, and Yuri are around, I would like to give like a couple of minutes for the attendees to ask any questions they have related to data science. Sorry about that, I forgot. Is that okay with you?
Sure.
Okay. So, hello everyone.
I'll stop sharing my webcam.
Yeah.
I'll pause showing my screen.
Yeah, I'm unmuting everyone. So if you have any questions for the panel, you can ask. It will be generic question. So, and after that we can get started with the lecture. So, you all are unmuted.
Just before we get started, the answer to the most obvious question is 42. For those of you who are not familiar with Hitchhiker's Guide to the Galaxy, I apologize.
It's the answer.
Yeah.
That's the answer.
Anyone, any question for the panel? Feel free to ask any question, like if you're confused about data science or anything. I mean, they have given a good background, but and I think, or you can raise hand if you can. It's better you can raise hand, and if you raise hand, we know who wants to ask question, or you can even chat on the window. Yes, Mr. Nagresh Kumar wanted to ask question. Give me a second. I will unmute you. Yes, go ahead. Hello, we can't hear you.
No, I have no any problem, sir.
Okay, so you have any question?
No, sir.
Okay, that's fine. Okay. All right, so I don't think we have any questions, so we can, Adam, you can continue. Sorry.
So
Yes. Yes.
basic RStudio interface. So this is the console is where commands are actually executed, but probably the most important piece of this is this panel on the upper left, which is the preferred way to execute commands. You can see I have some code, and in fact this is code I executed to actually create the HTML version of my lecture. And you can see there's a run button. So you can just write here and then run it from here. Now what's the advantage? If I want to know the log of 17, that's fine. If I want to know what 2 plus 3 is, that's fine. But if I want to do something more complicated involving significant amounts of computation, I may want to do something like this, where I've really written down a whole series of commands. And remembering this and doing this from scratch is not realistic. So what R allows you to do is create various kinds of documents, the most important of which is something called a script. So let me just show you a new script. File, new file, R script. And incidentally, the typical RStudio GUI is a little better than this. There's a little button somewhere around here that allows you to create a new script. For some reason, my machine has decided to be funny and not show it anymore. But I could just, in this thing, I could type in and then I have various choices. If I hit this run button, it will run the line. Source will run the whole document. But obviously, if I have 100 things I want to do and I want to do them over and over again, for example, if I have a data set and I have a standard set of analysis I want to do, I want to load the data set, I want to clean it in certain ways, I want to perform find out certain fundamental statistical information about it, I want to do charts, I can create a script, save the script like this, and then every time I want to do this to a new script, all I have to do is go to my script and do it, say what file I want to load and go it. On the right side, let me just put this further down so I can see it. You have something that tells you about what's in your environment. It tells you what data is available. So you can see at this point, well, you know, I have data sets called Adams data, C, weather, weather2, wine. We're not going to worry about what these mean, and values, which are sort of, I've been given certain characters. I've said certain variables contain certain information. The difference between values and data we'll get into later. Finally, this bottom right contains a lot of information. I have a files tab, which shows me what files are in the directory I've set as my working directory. If I do plot something, it's going to show up here. Let's just see, so I could do something silly. Plot x comma y. I think that'll work. There we go. There it is. Not very interesting, but you can do it. Packages, you'll be learning about packages this week. Packages, the basic R library contains lots and lots of information that is loaded as soon as you load R, and there's lots of things you can do. But there's more specialized information you may want or you may need it for a given thing, and those are generally stored in what are called packages. So you would load these if you needed to use them. I mean, and RStudio makes it very easy to load or add new packages or update, and then help is just what you think. All right, so that's the briefest introduction to that. As I said, this cheat sheet is very nice. And I think I've pretty much discussed 3 and 4. The command line, as I said, is this bottom left. And RStudio scripts are very useful because they're a very good way to store and save information. I think Hadley Wickham has some sort of statement that if you know you're going to do the same activity once, you just do it at the console. If you're going to do it 2 or 3 times, you need to then create a script. So just to make things familiar, I just want to start at the very begin, if you will, the very basics. You can use R as a calculator. It's tremendously overkill, but you can, and basic arithmetic operations work just as you think. 3 plus 2 is 5, 3 minus 2 is 1, 3 star 2, and star is the symbol for multiplication, is 6, and the slash, the forward slash, is division. You may occasionally make the mistake of, instead of typing 3 star 2, which gives you 6, you'll type 32 and say, I know I mean that. And of course, R is going to say, no, you mean 32. Now, this is mostly going to come up when you have abstract variables. And you do that for x when you mean x times y. Oops, excuse me. And if you do x times y, it'll tell you what you mean. More on exactly why it gives you that later. That's R as a basic arithmetic engine. The one, I wouldn't call it tricky, but important thing to remember, and if you've worked in any programming language, this is no different than any other language, and that is the order of the rules of operation is important. If you go 3 plus 2 divided by 4, it's going to say, I want to take 2 divided by 4 and then add 3. So 2 divided by 4 is a half, it's going to give you 3 1/2. If you want to take 3 plus 2 and divide that by 4, you have to put parentheses around it. 3 plus 2 is 5, divide by 4 is 1 1/4. So It's absolutely standard. And we can also use R. Any basic function you can think of. Exponentiation, square roots, logs, it's all going to work. So just I wrote some simple example. 3 raised to 2 is 3 squared is 9. Square root of 2. Log 10 is evidently 2.30 and some other stuff. Exponential of 10. And as we would hope, the exponential of the logarithm of 10 is 10. Of course, I just illustrated a few very basic things. Any function you can think of. If it's at all reasonable, you'll find it in R. And I think you'll find if it's not at all reasonable, but it's something you care about, somebody has written a package which if you install and load the package, will allow you to calculate that function too. So in future classes, we're going to have quizzes, which you will be forced to take. There'll be multiple choices. But since this is the first one, I thought we'd just, do a sing-along. I'm going to ask, so here's the first quiz. And if you have R in RStudio, you should do it and see if you can come up with the right answer. So my basic arithmetic, the quiz 1 is what is the log of 3 squared minus 2 times the log of 3? And quiz 2 is what is 3 plus 4 halves? I'm going to give you a few seconds. And while I'm doing that, does anyone have any questions? If you have questions, you can do it via chat if you like. If you do it via chat, what I'm going to do is I will repeat the question without your name, and then I'll answer it. So if you have any questions, that's probably the simplest way to do it. All right. Well, I know by basic property of logarithms, the log of 3 squared is 2 times the log of 3, so I better get 0. And by the orders of operation, this is going to, excuse me, it seems like we may have a question. Okay, so people are answering via chat. That's very good. And yes, the answers are respectively 0 and 3.5. Let's see that. To do this, I would do log of 3, caret sign is 2, minus 2 times log of 3. Notice I put spaces in between this. Completely unnecessary for R, very useful for human beings. When you put spaces in between your operations, it just makes it easier to read, and we get 0. And the other one was 3 plus 4 divided by, plus 4 divided by 2 is 5. Yeah, that's correct. 4 divided by 2 is 2, plus 3 is 5. Despite my PhD in mathematics, I do make simple arithmetic errors on occasion. And if you see any, please raise your hand and let me know.
I think Jyotirmay has a question. He has raised his hand. I'm unmuting him. So I think Steve, yeah, okay.
I'm not seeing it.
Just I answered that, sir.
Okay. Okay, yeah. So if you have already answered in chat, that's okay. Okay.
Okay. Actually, looking at those screens I was just minimizing, let me just take 2 seconds right now to talk about the text. I'm a big believer in sort of the freeware policy. And so I've made a strong attempt to find good books that were free or cheap. So the 2 texts, one of them is by Nell, and it's available for $5 Amazon. And so Amazon, of course, you can get the Kindle Reader. It's free. I believe I have it here. Yeah, this is the book. If I go to cover, this is what it is. And it's a very nice book. It really is a nice book on integrating R and statistics. He's a biologist. The examples are from biology, but is very nice. And the other is Hadley, Wickham, and Grollman's Introduction to R for Data Science. And I know the links are in the syllabus. You can read it online for free. If you at all think about buying books, it's a wonderful book. It's not very expensive, and you can buy. I own a copy. You know, I think it's a great book. All right, so after basic arithmetic, of course, that's a calculator. One main advantage of a computer language is that you can create variables and save data. So the basic ways of saving data in R, and we're just talking very high level. This is not precise, and if those of you who have done computer languages, let me assure you that this is nothing more than a sort of informal high level view, is R has vectors, matrices, and data frames. Those are the three main things. Vectors are, if you will, and I'm using this in the non-technical sense, are lists. They're just a sequence of numbers or data. Vectors don't have to be numbers, they can be characters too. Matrices are a little different. In R, first of all, matrices only will store data of the same type. So you can't have, you know, sort of one column be, you know, sort of red, green, blue, and another column be number of occurrences, 3, 4, 5. R will automatically turn that matrix into one where 3, 4, and 5 are the characters 3, 4, and 5. But matrices have dimension, and we'll stick almost exclusively with two-dimensional matrices because it's the very common model of rows and columns. So matrices have rows and columns, vectors just have one row or one column. Data frames are more complicated or more versatile. Mainly, as it says here, they can store mixed data. So if you wanted to have your data, which was, you know, number of houses, say, and so one column would be, you know, house type, you know, Queen Anne Ranch, and the other column was going to be number of bedrooms. You could have the number of bedrooms be a number if you liked, and the house type, of course, is a character. So they're more versatile. If you're familiar with these things, they are actually lists behind the scenes. But if you have data frames that are numeric, the numeric columns, you can do number stuff on them. And R will just be fine with it. Okay, so if you are curious, and there are times when you're not sure, in particular if something isn't working right, and you know your function says we need an object of this type, and you haven't provided it, and you say, well, I think I have. The function to do that is called class. So that's a very basic function. Class will tell you what it is. So here I just have some objects. Class of X happens to be numeric. The class of C is a matrix. Class of foo is a character. And the class of weather is a data frame. So these are the basic classes you're going to see. There's also logical. So let me give a sort of silly logical 4 equals 2. Oops. Equals 2. Oh, unexpected. Oh, sorry. R is very. So there's a logical. Now, incidentally, this is something that, as someone in the mathematical community, this defeated me for a very long time. These two things mean something very different. This first one equal sign, means you're saying you're assigning a value. This one means, are these two things the same? So it's very important when you're looking to compare things to remember to do the two equal signs. Otherwise, you're going to get this error message. But this is true, false, logical. Okay. So the other basic information you may want to know about an object is how big is it? Now, objects can have, so you're asking the number of elements. Length will tell you the number of elements. So my length of X is 5. Incidentally, if we go back to our R screen, you can see this on this environment on the right. You can see X. It says it's numerical and it tells you what it is. This is great when you have 5 numbers. It's not so great when you have 3,277 numbers. The length of weather is 14, and the dimension of weather is 365 by 14. So remember, weather is a data frame. And data frames, as I said, are these things called lists. So what this is saying is the difference between weather, which is a data frame, and C, which is a matrix, so the dimension of C is 2 by 1, that means it has 2 rows and 1 column, is that when you pretend weather is a matrix, it has 365 rows as 14 columns. Right? Behind the scenes, the length of weather is 14 says the list has 14 super elements, if you will. So usually with data frames, you're really only concerned with the dimension. In particular, you get more information. It'll tell you the number of rows, not just the number of columns. Are there any questions so far? Anyone have anything they want to? My chat window refuses to stay open. I know why. All right. No questions? All right, then I'll ask one just quickly. And we'll think about it for 5-10 seconds, and then I'll just answer it. What do you think will happen if I ask for what's the dimension of x? Remember, x is just a vector with 5 elements.
So,
Yeah.
I see. I'm unmuting Mohit. He has one question. So.
Okay. Please go ahead.
I think Mohit, you're self-muted, so you have to unmute your microphone, and then you can ask your question.
Yeah. Hello, sir.
Hi.
Sir, in the hello.
Yeah,
Yes.
I can hear you.
Yeah, in the RStudio ID. So can you please open the RStudio ID?
Sure.
Yeah. Yes, sir. In the line above, in the console, you have written the 3 plus 4 divided by 2.
Mm-hmm.
So between 3 and plus, there is a space, and between plus and 4, there is a space. But between 4 and 2, we are using divide operator, but there is no space. So is there any rule that where to use the space or not?
Yes, space is for human beings to understand. I mean, R doesn't need it. If I take 3 plus 4 over 2, it's going to give the same answer. It's about rules of operation. If I go 4 over 2, it's going to do that. If I go 4 space 2, it's still going to understand it. So, I mean, so your question really is, why did I put the space between the 3 and the 4 plus 2 and not between the 4 over 2?
Yes, sir.
I would just say that's because as a human being, me personally, this makes it clear to me that I'm taking 4 dividing by 2 and then adding 3 to it. If you, that's all. I mean, you know, I don't know, 3 plus 4 by 2. It just looks funny to me. I mean, I'm just used to, that's the way I personally would format things. It becomes, you know, more uniform, more critical for reading and more uniform when later on when we're doing complicated work.
Sir.
Okay?
Thank you, sir.
Sure. All right. So I believe I was asking what would happen if I asked what the dimension of x is. So I could just type it on the screen, but as I said, I can just put it here. So this is, notice this is one very nice feature of our studio, excuse me. When you do one side of a parentheses, it gives the other side automatically and puts you in the middle. Okay, so if I want to know what the dimension of x is, I can just hit run. It's going to say null. So the point is x doesn't have a dimension. Dimension is exclusively for matrices. All right. Let's see. Next slide. So, as I'm continuing this discussion, if we have objects that aren't too big, we can just print them on the screen and we can see what's there. So here I've said, so if you want to execute more than one command on a line, you use a semicolon. So this means show me X, show me foo, and show me C. And it shows me 1, 2, 3, 4, 5, 1, 2 in A, and 1 in A. More on this later, but the quotation marks means that it understands that this is the character 1 and the character 2 and the character A, rather than the number 1 and number 2, and an object called A. So weather was a little bit bigger. It's 365 by 14. That really wouldn't print on the screen. But there are two nice functions for examining data sets called head and tail. Head will show you the first, by default, it'll show you the first 6 rows of your data, and tail will show you the last 6 rows. So 1, 2, 3, 4, 5, 6. Well, this is 360 through 365 of the last observations. Notice that in both cases, it does it over 2 rows. R will automatically wrap very long things. There should be 14 columns. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I just decided that with the screen, I had my console, it couldn't print all 14 in a row, and it did it that way. Now, you may ask, what if you want to see more than 6 or less than 6? There's a parameter n, so there's a function, and you can tell it with that parameter n. So head weather, comma n equals 10 shows the first 10 values, and we can see the first 10 rows. Now, vis-a-vis the question I was asked, this is an example of what I mean. So head is a function, and what I've done is I've added space between the comma and my n. N equals 10, I didn't put space in because we understand that we want to assign the value 10 to n. So this is how you do this. And getting back to this as a data frame, you can see some of this data looks like numbers, and in fact it really is numbers, and you can tell that because it doesn't have the quotation marks around the numbers. Right? On the other hand, something like season is clearly a character, and since it's a data frame, R is very happy to have some columns be numeric and some columns be data. Let's see what the next slide is. Okay, so just to continue, another very nice function is something called summary. Summary, we mostly apply it to data sets, but it can be applied to other things too. But summary sort of, well, it gives you a summary. So see what it does. For each of the columns, it gives you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. Now, we're going to actually be discussing quartiles in week 1 briefly, but what this means is this is dividing the data. Now, day count, remember, goes from 1 to 365. So it makes sense that the mean and the median are going to be just exactly in the middle, and 1/4 and 3/4 of the way are there. Let's go to something more interesting, average wind. You see the minimum of the value of average wind, the maximum was 16.6 miles per hour, and the mean wind was about 4 miles an hour. So this would, if looking at it, this would tell you something. It would tell you that most of the wind is concentrated at the low end. There's a few very large winds, but there can't be too many of them because the mean is not anywhere near the middle, nor is the median. The median being 3.5 tells you exactly that half the time the wind was 3.5 miles per hour or less. Okay? So summary is a very useful function. And just getting a little ahead of myself, many R objects that are outputs of statistical processes have summaries where they can give you more information. Any questions? All right. So how do we create data in R? There's 2 ways to do it. You can put data in by hand, which there are times you're going to have to do either because it's some very novel data or it's a very small amount, and you can import it. We'll talk about importing a little bit later, but to create vectors, you use the equal assignment. So the very important new function we're learning here is C, which stands for combine. So x equals c of 1, comma 2, comma 3, comma 5 means x is the combine of 1, 2, 3, 4, 5. And we've already seen that if you print x on the console, you'll get 1, 2, 3, 4, 5. Now, as long as your data isn't too big, this is simple enough to do. Let me just give you one example. Mine, C equals C of.
I think there is one question. There's one hand raised, so I'm unmuting. Ajay, you have a question? You are self-muted, so you can unmute yourself and ask questions if there is a question.
I'm not seeing these people raising their hands. I don't know why.
You see, next to Ajay, there is a hand raise. No?
Yeah.
Ajay, you have a question?
I see. I'm going to have to.
Yeah, we'll check later. But let me check if.
I see. Yeah. So this is going to be problematical with large data sets. If I look at all my attendees and I scroll through them, I can see if someone's raised their hand. See, I see Ajay Kumar Singh has. I hope I'm pronouncing that relatively correctly. I know I'm good with Kumar Singh. Ajay has his hand raised.
Right, but I don't think he has a question. I don't see. Okay, so there is one way of yeah, I'm lowering his hand. So okay, go ahead. Or I think we can ask some of the attendees any question. I mean, go ahead and ask question. Otherwise, if you feel you are lost, and we can slow down the pace of the instruction. And you have to say something that if you're following everything,
Right.
That's very good. If you're not following, you can just speak up. I mean, Pritam wants to say something. I'm unmuting you, Pritam, so you can ask. Okay, I have unmuted you, Pritam. You are on self-mute, so you can unmute and ask question.
Yeah, am I audible now?
Yes.
Yeah.
Yeah. Hi. First of all, thanks, Adam and Manish, for a nice session. And yeah, it's going fine. And my question is very generic. That it will be helpful for us, at least for me, if you can give us a brief of prerequisites in terms of all those mathematical or statistical formula. I think what we should know before we start this course or the initiation of this course. In that case, it will be helpful that when things will be moving, that time we need not to recall everything at the moment. So that's generic thing I would like to mention.
Yeah, so this was a lecture 0, so we did not give you the assignment beforehand, but going forward, Stephen will give you the reading material which you are supposed to read before coming for the lecture, and that way you will be familiar with what is being taught, and these lectures will be more interactive, and we expect, as I was saying at the beginning, that in this course it's not one way. You would be expected to read the assignment which is given to you. So before the lecture, you will have material to read from these textbooks. And Adam, you have to say anything onto that?
Yeah, let me just echo what Manish said. In fact, the assignment for week 1 is already in Stephen's hand, what to read. After this was mainly supposed to be, or is mainly supposed to be, a talk to show you how R and R Studio functions, so you feel a little comfortable going into it if you have never used R or R Studio before. In the lecture, starting with lecture 1, the quizzes will be more formal in the sense that there will be multiple choice quizzes, and I will wait for everyone to answer, and then I'll go over the answer. So there'll be a reasonable number of quizzes. I will answer any questions as they come up. But going forward, the material that will be covered in the lectures will be given to you the week prior. Homework for the material will be assigned. I think my feeling is that they should be, sign it whenever, but they will be due the week after the lecture. So you'll have a week to think about, read the material. There'll be a formal lecture. And then the next week, in addition to reading the next week material, you will have the homework, which will hopefully be informative but not too long on the previous lecture. In terms of the mathematical background, this is not a mathematics class. It is statistics class, and certainly you need to be familiar with basic mathematics. I don't think there'll be very much. I'm not planning on doing any proofs. I will state some, results, and explain them, but without going through the formal, theorem proof method of doing things. I think one needs good analytical skills to do this, but I don't think one will need a lot of mathematical knowledge. We will be discussing matrices in week 1, and I mean, to some extent, that's a mathematical concept, but matrices, first and foremost, as in data frames, is a way of indexing data, and so it's not necessarily mathematics per se. Does that answer the question?
Yeah. Thank you.
Sure. For some reason, I don't know why this is. We'll figure this out prior to next week's lecture. I am not seeing when people raise their hands. I am seeing when people type chats. So if you wish to ask a question out loud, why don't you send a chat message? I think I'll see those, and then I can unmute you and you can ask your question. I don't know why it's the hand raising is not working on my screen, but it isn't. Or you can do that and Manish will interrupt me, which is fine. Either or. Okay. So I was just going to type something out very quickly, 3, 5, and now we see if I type this at the screen, I get 3, 5. Now, if I do this, and I just say I want to add A to this list, I'm going to get A is not found, because when you just type something, it thinks it's an object. So this ZZ is an object, and it's 3, 5. But if I type, excuse me, equals combine 3, 5, well, keep it consistent, 5, and now I tell it the character A. Now notice it says CZ consists of the character 3, the character 5, and the character A. And incidentally, I can combine works just as well with objects. And it does, of course, demand that I put an equal sign. And now I've assigned to ZZZ the values of ZZ and 2. And we see that ZZ is 3, 5A. And notice it's not the number 2, it's the character 2, because ZZ already was characters. All right. So this is simple enough to do as long as you have a small number of data. And another thing that's nice is colon will says just do the sequence. So 1, 5 is 1, 2, 3, 4, 5. Again, 1, 6 is going to print out 1 through 6. So these are just some things. And as I said, colon is, if you have a large number of numbers, colon is going to be very handy. If I want to create the data set of all the numbers from 1 through 100, X large equals combine 1, 100 is going to give me the numbers 1 through 100. And I can sort of check this. If I look at the head, the first two values of X large is 1 through 6. If I look at the tail of X large, it's 95 through 100. Remember, there's 6 numbers between 95 to 100 because you're starting with 0 when you subtract 100 from 95. And the summary of X large will show me all the data I've said. The minimum, the first quartile, that's the first 25% of data. The median, that's the value that splits the data in half. Half is lower than 50.5, half is greater. The mean, in this case, is the same. Third quartile and the maximum. So this is very useful. Now, just if you want more information about summary, and this is not just true of summary, if you hit question mark and then type that and hit enter, see what happened. It went to help and it shows you summary and it gives you the R information about summary. In particular, and this is very nice, is it tells you what the summary function is looking for. And notice it says it's not looking for a number, it says it's looking for an object, which, as I was saying, summary will work with all sorts of things. In particular, when we get to doing ordinary least squares and so-called linear models, you will use summary of the linear model object you create. It's very useful, contains a lot of information. But as I said, it works for anything. So LM happens to be the way you create a linear model. And you can see, it tells you what the information wants. Let's not worry about this. The only thing I want to point out now is you notice for a lot of the input, so it says input equals quotation marks QR, model equals true. So what this means is that this function has an input called method, it has an input called model, but if you don't specify it, it defaults to these values. So this can be very useful at times too. All right. And when you have variables, you can pretend they're numbers and compute them, play with them. So remember, x is 1 through 5. 2 times x is 2, 4, 6, 8, 10. X squared is the first 5 squares numbers, and log of x. I knew the log of 1 is 0, and the rest of these are, of course, just what they are. And you can combine numbers. So if I have y is 5, 4, 3, 2, 1, x plus y will be 6, 6, 6. X times y, it's just, so this is important to know. When you tell R to do an arithmetic operation on 2 vectors, it just does a component y. So x plus y is it adds the first 2 components of x, the first component of x and y, then the next component is the second component of x plus the second component of y, etc., etc. Which brings us to a very important point. When you do arithmetic operations with R on vectors, please make sure they are the same length. If they are not the same length, R won't say, sorry, I don't know what you're talking about. It will throw what's called a warning, which means we're going to let you do it, but we need to tell you things might not be what you want. And in this case, so I create this object z, which is 1, 2, 3, 4. X has 5 elements, so what's going to happen in the 5th place? Well, when I add x plus z, it says warning, longer object length is not a multiple. And then it says, well, it makes sense, because 1 plus minus 1 is 0, 2 plus 2 is 4, 3 plus 5 is 8, 6 plus 4 plus 6.2 is 10. And where does this 4 come from? R has very specific and very special rules on what it does when it has objects of different lengths. Okay? And unless you are very familiar with them, it is just simpler, significantly simpler, to make sure that you never try and do arithmetic operations with vectors that are different lengths. I've been actively using R for over 5 years now, and I cannot think of one time when I found it necessary to do arithmetic operations on vectors of different lengths. So just a word of warning. If you do this, you will get results that are probably not what you want them to be. Okay? And here it is, it's written out. Best rule, only do arithmetic on vectors of the same length. That way you will not have to figure out what's going on. All right, let's, so why don't people just sort of answer with via chat. I will make sure it's open. And you don't have to answer, but what function will tell the length of a vector? It's from a few slides ago, but who remembers? All right, next, in answer to a question, next week when this is done, this will be an interactive quiz where you will have a screen pop up with multiple choice answers and you'll get to select one, and we will wait for people to finish. Okay, but it's the length function. And how about a matrix or a data frame? What function will give the length of that? Well, let's think about it. I made a point of saying that matrices don't have length, they have dimension. Data frames have a length, but really we're more interested in the dimension. So length gives you the length. The length of x large is 100. I created something called character vector. This says length 2 because there's 2 characters. Now incidentally, if I create char vect 2 equals phi of, oops, excuse me, A and BB, what do you think the length of that's going to be? I mean, there's in some sense 2 obvious choices. There's 3 characters, A, a B, and a B, so 3, or 2, because I've sort of said there's only one, if you will, comma separating it. The correct answer is 2, because I have one character that's A, and there's another character that's BB. And if I type length of char, okay, so what you're seeing is a very nice feature of our studio called auto completion. After 3 or 4 characters, it'll offer you various choices. So if you hit enter, it'll just complete the one you've chosen. And it is 2. Okay. As I said, question 2 is semi-tricky. If I ask for the length of weather, it'll tell me it's 14. But really, the more important thing is to note that weather as a data frame has a dimension. And its dimension is 365 by 14. So
Adam, I think there are a couple of questions on the chat. So I think there's one question from Hemant at the bottom. It says, is that length in the context we are talking? So I'm not sure what he means.
I'm not seeing when people raise their hands.
No, it's on the chat at the bottom. Do you see his chat? Hemant, I have unmuted you. You can unmute yourself and ask questions, what you wanted to ask.
Thank you, Manish. What I wanted to ask was, when we talk about dim function, it basically gives the dimensions of the data frame or the vector.
It gives you the dimension of a data frame or a matrix.
Yes. So that is what I wanted to put across. We will not get length of the data frame by just giving the dim function. So what would be the right answer for that?
Well, my point is for a data frames actually do have length. Okay, so vectors have length, they don't have dimension. Matrices have dimension, they don't have length. Data frames have length and dimension, but the really important one is dimension because it gives you the length and more information. It gives you not only the length, which is the number of lists, and then it gives you the length of each of those lists. So let's so if I go dimension weather, it says 365 by 14. If I say length of weather, it says 14 because there's 14 lists, if you will, but really maybe just simpler to say there's 14 columns. So if you say length, it just says how many columns there are. If you say dimension, it says there's 14 columns, and each of these columns has 365 elements in it. If you will, it's 365 rows and 14 columns. So let me see. I'm just going to create something called matrix object equals so if we look, I've created this matrix. If I say dimension main object You see how it's autofilling for me, even though I've capitalized correctly? That's a nice little thing. It's 2 by 2. There are 2 rows and 2 columns. See, so it's not giving, when you take the length of the matrix, it's just saying, well, I can think of it as something with 4 objects, but if you're losing information. You're losing things. So I mean, if I just say, well, let me not get into too much detail at the moment. It will be covered more in the reading this week. This allows me to say, I want the second object in the first column is 2. I want the second object in the second column is 4. The 2 by 2 matrices, when you have 4 elements, all roads lead to Rome. But imagine you have a data set, even a very small one, like this weather or wine, 177 observations. Imagine if you say, I want the 31st observation of the 7th variable. Finding that would be very complicated. But with, we're going to, why this notation is correct will be explained this week in your reading, and we'll talk more about it next week. But if I want the 35th observation of the 12th variable, I just do it that way. So you lose information by going to length. So certain objects have, you should think of matrices as having dimension, and you should think of data frames as having dimension. You can get the length, but you should really think of them as being 2-dimensional objects with 2 attributes, number of rows and number of columns.
Okay. Thank you. My context of the question was a little different. When I was talking about this length, when we have this dimension, we always say length is, let's say, 5. If it is a word, we have, let's say, this word contains 10 letters. When it is a numbers, then we say, okay, it is 10 digits. But when we talk about length of a matrix, then does that mean we talk about the total number of total number rows and columns in that matrix, correct?
Well, it's the number of rows times the number of columns.
Yeah, number of rows times number of columns.
Yeah.
So when we talk about length, we talk about the number of rows into number of columns. That's pretty much it.
Yeah, I mean, my main takeaway would be that you shouldn't think of the length of a matrix. You should think of the dimension of it.
Mm-hmm. Okay.
See, it's 2 times 3. But of course, you know, I mean, how many elements are in a matrix? It's the number of rows times the number of columns.
Yes.
Right? But, I mean, all right, so let me just say this. The point of creating a matrix would be would be in a situation where you care about defining your any particular element of it as sort of 2 characteristics and how you would find it. And so you lose information if you just talk about length. I mean, yes. So, I mean, for example, I can also make this a matrix with 3 rows. Now if I see matrix object, oops, it's going to change the way it looks. So that's different from if I have, so this is 3 rows and 2 columns. It's a different object than if I have 2 rows and 3 columns. So if I go back here, I've changed it. Now you see, if you look, this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 5, 5, excuse me, not 5, 6. So in terms of just elements, these are the same. As matrices, these are different matrices. So the point is if you just talk about the length of a matrix, you're losing information. It's conceivable. It may not be that important, but frequently it is. So when you do matrices, you should always stick to the dimension, even though they do have technically aligned.
And Adam, there was one more question. I'm just chatted it.
Can we have a character repeater, like we do for 1 through 9? I see. Yes, there is one. It's SEQ, but it gets a little bit. There's a function called sequence, and there's a function called rep for repeat, REP. So, having given you that information, it's REP. I think REP will work in this case. There you go. And as you see, I hit question mark repeat, and then it shows you. So I have repeat a. One thing I will say is that for things like R, Google is a tremendous resource. If, you know, outside these lectures, if inside these lectures you ask questions, but outside these lectures, if you just ask the question in Google, inevitably you will get great answers right away. So there is a character repeater, but the other thing I should say is this is different from, you know, my 1:5 gave me 1 through 5. It didn't give me 1 5 times. There is a way to get, you know, sequences with characters too, but it's more complicated because you have to understand how sequences are enumerated. Okay. All right, so importing data. As I said, in addition to just putting all the data in by hand, the most important way is to import data is to already have the data in some form. Maybe it's an Excel spreadsheet, maybe it's just a notepad. And we're going to discuss data importation in more detail, but just so you can get started with and have some fun, the most basic and important way to import data is a function called read.csv. And CSV stands for comma separated value. And I don't know how to put this. Okay, so a comma separated value file is one where the different data points are separated by commas, and different rows are on different lines. But sometimes comma separated values have something besides the comma that separates them. And we see is with the function read.csv, you can do that. So for example, here's an example of using if the data is already in your machine and stored in the directory, which is your working directory, read.csv will import the data into R. So here I see read.csv, and I told it the file's name is weather_2014.csv, and that's where that weather file comes from. This SEP command says that, in fact, it's not a comma separated, but it's a semicolon separated file. But CSV understands comma, semicolon, and lots of other things. String as factors equals false means that if you have a column that's a string, you should think of it as a string, not a factor. Let me just, well, I said before I gave a very incomplete description of data types. Another kind of data type is a factor, and they come up in statistics a lot. I will just briefly say right now, for now, that sometimes you have data where the values it can take is one of a small but fixed number of values. So for example, if your data set is about houses, you might have the number of bedrooms. Houses don't have 2.3756 bedrooms. They don't have 4.6 bedrooms. They don't have log of 8 bedrooms. They have integers, bedrooms, and in some cases they are now talking about half bedrooms or even quarter bedrooms. But that's it. There's a finite number of rooms. In addition, you can have things like color. Or here's a very good example. We have direction.wind. You can see wind is going to be, you start with south, west, north, and east, and you can go up to 3 ways, like south but southwest. So there's actually a very finite 4 times 4 times 4, which is 16 times 4 is 64 different possible wind directions. you can consider that as a factor. Wind direction can only take one of a finite number of values. Wind gust, on the other hand, is numeric. This is not a factor because essentially any number could be the wind gust. Okay? You can't a priori say there's 100 different wind gusts. Right? So string as factors equals false says import the data set, and if you have something that was a character like season or direction, think of it still as a character. So you could do character operations on it. Okay? So this is just sort of a piece of background we'll discuss in more detail later. But more importantly is, let me just go back. So if you have your data set, so for example, you may download from the web a data set. I don't care what it is. And you just put it in the working directory, and then you can say read.csv. And incidentally, data comes in Excel files. You just rename it as, instead of .xls or .xlxs or whatever, you just rename it as .csv, or, save as .csv. And then you will be able to import your data from your Excel spreadsheet directly into R. The other thing is if you happen to know where your data resides on the web, you can import it directly from the web with read.csv. So here I've written an example, read.csv, and what is it going to read, or which means read into R? It's going to read into R what it finds at the URL, and here it just gives you a URL. Notice since it's a character, you have parens, and R doesn't care if you use the 1 or 2 quotation marks, and it'll just import this data set. Now, if you want to go and play with data sets, if you just go to uci.edu.ml, or if you Google UC Irvine Machine Learning Laboratory, you'll see that there's a huge number of databases there. String as factors is it like categorical data? So I think I've answered the question, but in case I haven't, string as factors, if you say nothing to the read.csv factor, anytime it sees what it thinks is a string, it's going to turn it into a factor. Okay? So factors are categorical data. So it's categories of that. Trying to see if there's an order here.
No more questions. There's a discussion on the RStudio download, so that's fine. Adam, there's no more questions.
Okay. Yeah, if you haven't downloaded RStudio, just put in your browser download RStudio. Just similarly, you download R from the CRAN. The information of where to download both of those is discussed in the syllabus. I did have a earlier in the thing a link to the RStudio IDE cheat sheet, and that is in this lecture, which will be up on the web very shortly. That's it. Are there any more questions? Anyone raising their hand or chat? Okay, so very shortly you'll receive information about the reading assignments for next week and the homework, though that's not due for 2 weeks. And, if there's no further questions, that's all I have to say. This was not, going forward, I sincerely hope things will be more interactive. You will certainly be asked to do a number of polls, and hopefully as you go on, more of you will feel free to ask questions, and questions are good. I mean, the bottom line is, I always take it as a given that if one person has a question, there's probably at least somewhere between 25 and 95% of the audience who has the same question, but everyone's afraid to ask. One of the advantages, there's many disadvantages to being old like me, but one of the advantages is I've been in enough of these situations that I just ask questions. I've realized it's far better to ask and figure out what's going on than to sit in ignorance and worry about what people think. So ask questions would be my takeaway, and hopefully things will be more interactive, which will be more fun. That's all I have to say. Manish, do you have anything you want to add?
Yeah, there are like few questions on the chat. So one being the recording. Everyone must have received their log in and password the credentials for Talent LMS, ACADS Talent LMS, which is the repository for the course. You should all try to log into that portal to make sure you have access. The course video will be uploaded to the link for the course video will be available through that portal, so you can go and watch the lectures if you missed or you want to go through certain sections again. People are asking about the course book. So the course books are the same, which are there on the course website. There are 2 course books, and those were also sent out in the mails earlier. So please follow.
This lecture.
It was mentioned in this lecture as well. So we are not going to spam you with a lot of mails, but if you receive emails from either me, Adam, or Steven, make sure you go through that email, okay? That's the only way you will be able to follow all the instructions. There will not be too many emails, but whatever the email you're receiving, that will have some useful information. So there are 2 textbooks. You can go to either the mail or the ACADS Facebook group, or to the LMS. Everywhere we have mentioned what the course book is going to be. Don't try to follow too many things. That will be a problem because you won't learn anything. Just follow what's being, at least for the people, if they're very ambitious, they can try other things. But if you want to get some basic skills and get a good foundation, try to follow with these minimum things we have prescribed for the next 12 weeks. And I think you'll be good. And you have to work with us. So that's pretty much it. Any other questions you can post on the chat, or you can raise.
Answer, but right after you started talking, Manish, a bunch of chats showed up on mine. Okay. So you answered most of them. As I said, the texts are listed by name. It's this book, Introductory R by Robert J. Nell, and the other one is by Hadley Wickham and Groleman. I don't know his last name, his first name, but it's the title and where to find it on the web is both in the syllabus, so you have access to that. There was one other question I wanted to answer. Why is R not considered for big industrial use? And the answer to that question is it is considered for big industrial use. It's used in it is used in big industry. The thing you have to understand about R is it's a wonderful language for doing statistics, for understanding your data, and for creating models of data. It's, in my opinion, the best language for that. If you need to deploy a system, R is not good for that. So you will not find many companies where R is the only language. And you have if all you're doing is creating reports, R is really the best thing. And it is used all over the place in big industry. So, and somebody says, like SPS, it is integrated with big data platforms. That is true. You can do data sets as large as you want with R, with cloud-based things. But if you have a computer with decent amount of memory, you can just, data sets have to be really large before you have to get off your computer to do it.
Also, companies like Deutsche Bank, CSFB, BlackRock, the pharmaceutical companies like Pfizer, Bristol Myers, they have all their research platform on R. So it's wrong to say that R is not used in industry. It's one of the, it's heavily used wherever there people are doing like data-related research. The second question was, should we ask questions more on statistics and core data science rather than mundane technical questions on tools? In the first few lectures, you feel free to ask all those technical questions, but for technical questions, you can find answers very easily on Google or other places, but this platform is meant for more, you can ask questions definitely, and then you can post those questions on LMS as well, and Stephen can answer those questions, but this is more for asking some conceptual questions in statistics. This is a course in Introduction to Data Science, not an R programming course. So focus will be more to get you up to date, get you started and up to speed with statistical concepts. And we'll make you do a lot of projects using R. So by the end of it, you will be pretty much familiar with R syntax and how to use it. That's pretty much it.
So what I would say is you're going to learn R, but you're going to learn R as a byproduct of using R. You're not going to learn R because most weeks we're not going to sit down and say, this is the class of objects that exists in R. Here's all 6 of them, memorize them. You're going to learn what the various classes of objects are from us having used the class of objects. I'm not sure what mundane technical questions are. I agree with Manish, and when I have questions, I frequently will just Google. Google is an amazingly good resource for technical questions. How do I do this in R? In fact, the way I learned R was the original language I worked in at the first shop I worked at. They used MATLAB. I became pretty reasonably familiar with MATLAB, and when I started to learn R, I kind of knew what I wanted to do. I just didn't know R syntax, and I learned R syntax by saying, I know I want to do a for next loop. How do I, what's the syntax of for next loops in R? Well, I just Google, how do you do for next loops in R? And somebody has examples, and it goes on. So that will be good.
Yeah, that's very important, Adam. As Adam said, it's more important to know what you want to do. How you want to do, you can always find, then you have a lot of resources. What is very important to know is what you want to do with the data.
Okay, somebody said, I don't want to waste time for all these great scholars by asking questions which can be easily Googled or by self-explanation. So, you're sitting here, there's no reason why you can't, if you have a question that you think is technical, Google it. And if you come up with a good answer, that's fine. If not, then maybe it's appropriate to ask.
And if you find some good answers and you found some useful resource from Google, post it on the discussion board of the class on the LMS, and it will be useful for other people and for us as well. Probably we'll learn from you as much as you are going to learn from us.
I hope so.
Yeah. So there's another question from Mr. Nagresh Kumar is asking, can you compare if R with Python and MATLAB? As I'm feeling its programming style are same as Python and MATLAB. Adam, you want to take, or
no, I'd like to answer that question. So, in there's strategy and there's tactics. We mostly think of this in terms of military, but it applies to most things. So, what's the difference? Strategy is your grand scheme of how you want to do things. I want to take Vienna. Tactics is how you're going to do it. We're going to take Vienna by encircling and coming up from the rear and attacking from the rear. We're going to take Vienna because we're more powerful than them. We're going to bomb them for 2 days, and then we're just going to march right in. So strategy for all languages is exactly the same. Tactics differ, and tactics in computer languages is called syntax. So I would expect that essentially anything, what you can do with R, what you can do with Python, and what you can do with MATLAB are essentially identical. How you would exactly implement them, which is the tactics or the syntax, differs. So it's much like learning languages. If you're already familiar with Python or MATLAB, learning R is going to be orders, not one, but orders of magnitude simpler. Everything is going to be similar. As I said, when I learned R, all I really did was sort of say, I know it's a programming language. I know what I wanted to do. How do I do it in R? And Googling that was amazingly similar. So programming styles, I mean, the cognoscenti are going to argue with this and say, well, Python does this and it's very different, and blah, blah, blah. And on a final level, they're right. But on an introductory level, they're all very similar. I'm teaching this in R. I think R has a better set of statistical tools than either Python or MATLAB, though I don't, anything that we're going to do in the next couple of weeks can easily be done in any of them. I would point out one difference between MATLAB as compared to R and Python, and that is that R and Python are free. They're open source, whereas MATLAB, Matrix Laboratory, is a commercial product that you need to generally buy. If you're a student, it's very cheap. If you're not a student, it's not so cheap. I like MATLAB. I have fond memories of it. I just think, given the power of computers and the power of human beings who are spending all this time thinking about writing R and Python code, that except for very specialized uses where maybe MATLAB just knows a lot more than many people, there's really much less need for it. When I first started coding. The reason we did matrix was our head quant wasn't R guy, but even he agreed that R was just too slow for doing things that weren't going to be part of research projects. That's no longer the case. The speed of R and the speed of computers has increased so much in the last 5 years that R is realistic for many things that it wasn't realistic for. So I don't know. I hope that basically, I mean, in the greater picture, they're all the same. The differences in the details, and as you go along this class, the difference will become more clear. Are there any other questions below that? That was the last question. So I think that's about it for today. Is that correct?
Yeah, I think, and again, Stephen, the course TA is very, very knowledgeable with R and statistics, so he will be of big help. Also, the TA session will be a lot more interactive, where you will be required to ask questions. And I will repeat that the best way to learn is ask questions. The people who will start asking questions from the beginning will be the ones who will follow the course more closely. So make sure you ask questions, even if you think it's silly for the first couple of lectures or during the course. It's okay if it's silly. It's not, there's no silly questions. It's okay, because we do not expect that you have a lot of background in statistics. No, or R, yeah. So thank you. Thank you, everyone. And again, thank you for joining this session today. Today, Adam and Niels, as Jadip was saying, it's kind of an NFL final going on right now in India. It's an IPL final, cricket final, and still these guys are here. So hopefully the next week we'll see a lot more people. Okay, thank you very much.
I'm going to all right, I'm going to end my participation.